now and get it over and done with. With this question two says, given the quadratic pattern 5, 10, 17, 26. This looks like such a generic question. Write down the next two terms. Okay, I mean, like, depending on how many past papers you've done, I mean, like, you will already know what's coming from all this. They're probably going to ask us to get the general term, and then they're probably going to ask us to use the general term to get something. You know, it's just so straightforward. So don't lose marks like this because it's so easy. 10 minus 5 is 5, 17 minus 10 is 7, 30, 26 minus 17 is, I think, 11. Is it? No, 9. Oopsie. So the second common difference here is just 2. That's the second common difference. And then you can just work backwards. So you working backwards, all you have to do is, you see, it's like 5 plus 2 is a 7. 7 plus 2 is a 9. So meaning here, 9 plus 2 would give you 11, you see. All that's happening from the top here, it's just 5 plus 5 is 10. 10 plus 7 is 17. 17 plus 9 is 26. 26 plus 11 is giving you 37. And then down here, you know the second common difference is a 2. So 11 plus 2 is 13. And then here, 37 plus 13 is going to give you 50. That is the way we like it. So the next two terms, they're just 37 and 50. That's going to give you 2 marks. Ka-chow. Anyways, the next one, as we have already predicted, they're asking for the general term of the pattern for 4 easy marks. So all we need for the general term is, yeah, we technically just need this actually. Yeah, we literally just need this part of what we've just written out, because all we need is the numbers on the far left here. 1, 2, 3. The one right at the bottom, we're gonna make it equal to 2a. This one, we're gonna make it equal to 3a plus b. This one, we're gonna make it equal to a plus b plus c. Now, this is already something a lot of people know, which is good because it's 3 marks. Working out your formula, we know we just need to get Tn is equal to an squared plus bn plus c. We're gonna start from the bottom as usual. 2a is equal to 2, so a here is a 1 because you're gonna divide both sides by 2. You're gonna throw a 1 there, and then your b here is 5 minus 3, which is a 2. Here you're gonna put a 1 plus 2 plus c is equal to 5. And then your c value here, this is a 3, right? So when the 3 goes to the other side, it's going to be 5 minus 3, which is a 2. Now, yeah, these I have to test them out when we're done because we're moving way too fast. So let's see here. N is a is 1, right? So you're going to put a 1 there, which is just n squared because there's a 1 there. There you're going to put a 2, so it's like 2n. There you're going to put a 2, which is a 2. Now you want to test out your answer. You can test out by putting, let's say, n as 4. You want to put n as 4 and see if you're going to get like a 26 there. So I'll just do that now as soon as we are at our fallen comrade here. So let's do that. So let's see if putting in n as 4 is going to give us 26. If n is a 4 here, it's 4 squared is 16. 16 plus 8 is like 24. 24 plus 2 is 26. Yep. It's 4 marks in the Z bag. Now, the next question here, also out of 4, right? It's saying which term in the pattern will be equal to this value. So as already said in the beginning, you know, these questions, you can almost predict what they're going to ask. They're going to ask for the next 2 terms, then they're going to ask for the general term, and then they're going to ask for a specific term in the sequence. It's quite straightforward. Always get those marks because they're 3 marks. So they want us to get which term in the sequence is equal to this. So this is Tn. And then they're asking for the value of n that produces this value of Tn. So they're saying which position in the sequence gives you this term. So Tn, where Tn is, we're going to put 1765. And then we just need to solve for n. And solving for n here is just the quadratic formula. So you're getting 4 marks for using the quadratic formula, which is like nice. You see, so 2 minus this number gonna give you 1763, like that. So let's put this in our calculator, or rather in the quadratic formula first. Minus b plus minus b squared minus 4ac all over 2a, and here's minus b plus minus b squared minus 4. A is a 1, c is this number, and then what you got? 2a is a 1 over there. Nice, nice. So let's just be careful. Oh, I don't have a calculator. Yo, somebody's gonna have to work it out, please. Like, oh, please take one for the team, because yo, this boy don't got a calculator, and it's kind of far. Like, ish. Trust me when I say it is far. So if anyone has a calculator, please do the honors, and save the pandas, and please give us the answer. But if you're going to do it with your head, let's see here. Well, the first answer is definitely gonna be invalid, because it's like what? I think n is negative 43. Other one, no. Hey, goodness. That one's gonna be a 4. But this one we have to disregard it. But no. Can someone with the calculator please confirm the answers? Otherwise, we is going to be stuck. And being stuck is no. I think it's 41, not 4. Well, where did I write 4? I meant 41. I forgot the 1. So, anyways, let me see if there's something in the chat box here. Problemo 41 or 23. Oh, thank you. Yes. So this one is not valid because it's a negative number. You cannot have a position that's like position negative something. It doesn't make any sense. But anyways, moving on. What does it say now? You have here. Yeah, that's that for 2.1 actually. 5 marks is 5. The fifth question here is a classic question. They love this kind of equation. It says the first 24 terms of an arithmetic sequence are these. This is important. They're telling how many terms you have. First 24 terms, meaning starting from here until here, you have 24 terms. This is T1, T24. And then they said, calculate the sum of all natural numbers. This is where you need to know what natural numbers are. Natural numbers are numbers starting from 1. You see, 1, 2, 3, 4, 5, going all the way to infinity. Those are natural numbers. They say calculate the sum of all natural numbers from 35 to 196. So if they're saying you should start from 35 to 196, I mean, like, natural numbers are all the numbers from 1 to infinity, yes. However, if they're talking about natural numbers from 35 to 196, then you need to be thinking of every consecutive number from 35, meaning you're going to think of 35, 36, 37, 38, going on and on. These are all the natural numbers from 35 going to 196. It's consecutive numbers, one after each other. So they say calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7. So this question, it's quite common, not specifically these numbers or whatever. No, what's common is this part. They're not divisible by whatever, or even sometimes they'll say divisible by whatever. So if anyone has like gone through the sequences and series course, I mean, like, you've probably bumped into a couple of these already because they're just so common. Now, these kinds of questions, you always look out for the kind of a sequence you're given. Now, the kind of a sequence you're given is never a coincidence for these kinds of questions. The sequence you're given always goes with the question, because if you look at this sequence, it's so blunt. This sequence literally has multiples of 7. You can see here it's 35, that's a multiple of 7. 42, that's a multiple of 7. 49, that's a multiple of 7, going all the way to 196. These are all multiples of 7. Specifically in this sequence, or series rather, you have multiples of 7. Like we can see it. It's so much in our face. Now the idea is this sequence has multiples of 7s only. But then the question is asking us to add up every single number from 35 to 196. That is not divisible by 7. I'll repeat. Our sequence looks like this, but then the question wants us to add 35, 36, 37, 38, 39, 40, 41, 42, 43, going on and on. I feel like you get the idea. So if our question wants us to add up every natural number that is not divisible by 7, this is what you're going to do. And this is a method you can use for all questions like this because it's the same way of thinking anyways. So what you're trying to think of is you have all these numbers, right? From 35 all the way until 196. Now what you want to remember is amongst all those numbers, right? You have a number that's divisible by 7 here, and then somewhere here another one is divisible by 7, and then another one, and then another one, and then another one, going on and on and on and on. You have all these numbers here that will be divisible by 7. All of them, all the way until 196. The ones in the middle, those are the ones that are not divisible by 7, you see. The ones in the middle here are the ones that are not divisible by 7. If you're thinking of all consecutive numbers from 35 to 196. Because if you look at how I was even writing it out here, right? 35 is divisible by 7, right? But then every one of these here, all the way until like 42, none of these are divisible by what you call by 7. And then what we already can see is that this is going to be happening over and over again until 196, because between 35 and 196, I mean, more numbers are not divisible by 7 than the ones that are divisible by 7. But without making anything too complicated, if the question here is saying calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7, they want you to add up all these numbers that are in between the numbers that are divisible by 7. Now to do that, it's actually quite simple. All you have to do is you have to add up every natural number from 35 to 196, meaning every single number. You have to take 35 plus 36 plus 37 all the way to 196. You have to add up everything. After adding up everything, you need to subtract the ones that are divisible by 7. You see, because if you add up everything and you remove the ones that are divisible by 7, you're going to be left with the ones that are not divisible by 7. You see, I'll repeat. If you add up everything and you remove the ones that are divisible by 7, the ones that you're going to be left with are the ones that are not divisible by 7. You see, now the fortunate thing is adding up everything is easy. Adding up all the ones that are divisible by 7 is also easy, because you'll then just be able to say everything together minus the ones divisible by 7. You're going to be left with the ones that are not divisible by 7. Now adding everything up is quite straightforward. You're going to use your SN formula, because that's the first thing you need to do. You need to add everything up, meaning you want the sum of everything from 35 to 96. Now the idea is, if you're going to add up terms or numbers from 35 to 196, you can use this formula. Sn is equal to Sn is equal to n over 2 a plus L. You see, this is one of your Sn formulas for an arithmetic sequence. You can use it as long as you have the first term and the last term. You see here, first term, and then here you have last term. You see, now adding up everything, we can just use that formula, because we have the last term, which is 196. We have the first term, which is 35. Now we have to be careful about what we make n. N This is something very important, and this is something that always kills people. Your value of n is always the last term minus the first plus 1. That's if you're adding up all natural numbers from one place until another place. You always have to say the last one minus the first one, and then you plus 1 for you to see how many individual numbers you're dealing with. Now, to make better sense of this, let's use fewer numbers. If you had the numbers 1, 2, 3, 4, and 5, and you want to add them up, if you look at it nicely, you're adding up 5 numbers. But then if you had said you're adding up 5 minus 1 numbers, you'd be wrong. You see, you don't, if you want to add up numbers from 1, 2, 3, 4, and 5, you don't say that. Yeah. Hello. Yes, madam. I think the network is like not doing the things. But let me see. If the network is like not clear, you can write out your question.
No, I just wanted to say,
You wanted to say what? Oh wait, the network. I cannot hear. I think because of the rain. Because it's been raining the whole day today, like literally, properly. You can type it out. You can type it out. Send. So you can type out the question. I'll just come back to this just now. But then what I'm trying to say here is, if you're gonna add up, if you wanna see how many numbers are there between 35 and 196, you're gonna have to say 196 minus 35, and then you have to plus 1. So in your calculator, let's see what this gives you. 196 minus 35 plus 1. This is telling you actually have 162 numbers that you're adding up. You have 162 numbers that you're adding up. That's the value of n. So what I was trying to say is, the easiest way to look at it is, if you're looking at, let's say, fewer numbers. Let's say you were adding up numbers like 2, 3, 4, 5, and 6. So you can see you're adding up 5 numbers here. But then if you had said the number of numbers you're adding up is 6 minus 2, you'd be wrong, you see. Because if you're adding up numbers from 2, 3, 4, 5, and 6, you're not just going to say 6 minus the 2 there. You're going to have to say 6 minus 2 plus a 1, so that you can include the number in the front there, so that you can see your 5 digits. And let me re-add Chloe, because yeah, I think her network was ring, so I couldn't even hear her either. But anyways, I'll just add her now, and then we'll see what she's going to ask. But then before that, let's see here. So adding up everything here, right? In our calculator or in our formula, would have put here S162, N would be like 162, and then A, the first term, which is like 35, A is like 196. Everything in the calculator. Let's see what it gives us there. Blah 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 blah, yada yada yada. So everything in the calculator here. Wait a minute. Yeah, everything in the calculator here is giving us 18,000. Let's put it here, 18,000. 711. Before I move on, are you back, Chloe? Do you have your question so that we can answer it or not? But if you don't have a question anymore, let's just carry on and finish for now. So this is the sum of absolutely everything. So in addition to the sum of absolutely everything, you want the sum of the ones that are actually divisible by 7. So the ones that are divisible by 7, you adding all these up, you can use the same formula. Sn is equal to n over 2 a plus l. Because here, the only issue here is, you see you have 24 terms now, instead of you dealing with the whole whatever 162. in this sequence, you have the first term is this, the last term is this, right? But then you're not dealing with natural numbers here, you're dealing with just these ones. So you already know that they told you have 24 terms. So n is a 24. The first term here is 35, the last term here is 196. All this in the calculator. Let us see what this gives us. Or in the head rather. It's 12 and then 196 plus 35. You know, this is dangerous, blah, blah, blah. 231 times the 12. 2 times that. 2 plus 2 times 1 is a 2. Okay, so this will be 2,772. If you've worked it out in the calculator and you're getting something different, please let the boy know before the boy messes up good. So you see, this is the sum of absolutely everything. This is the sum of the ones that are divisible by 7. So the sum of the ones that are not divisible by 7, it's going to be 100. It's going to be like the 18,711 minus 2,772. And then let's see what that would be. 2 minus 1 would give you, oh no. This is no, it would be 1 minus 2, it can't, so you'd have like 11 minus 2, which is like a 9 there. And then I think you'd have like a 3 here. And then another 9 there. Oh yeah, 1 5. 15,939. That is going to be the number that you get if you add up all the terms or all the numbers that are not divisible by 7. So yeah, this question was, it's not like one of a kind. Nope. If you go through like multiple past papers, then you're gonna bump into these questions multiple times also. You see, so this paper is mentioned, this is just the June paper, June 2018, paper 1. And as you can see, we have just done what we have done. Now let me actually just stop the recording ISO, because we are is done. Stop.